Okay. 33. There it is. Wait, what were the directions? Find the Taylor series centered at C. Find the interval on which the expansion is valid. Okay. So, with this guy, what's going on here? Wait, what? That doesn't look like anything. What the heck? Well, let's just see what happens then if we do this through brute force, and then you start to see what's happening. So remember, to find the Taylor series expansion, then if we don't have like a nice formula, like a shortcut formula, just got to use the long one. So you got to find all the derivatives. And I was looking for a pattern, but actually I noticed after this point, look at that. Derivatives are just going to be 0. You plug in, you get these values. And so then you can just plug in and, using the formula, where the nth term is just the nth derivative over n factorial times x minus c to the nth power. So that's where all these terms are coming from. And then that's it. But wait a minute. This actually makes sense because we started off with a 4th degree polynomial. It's already a polynomial. It's just not written in a way that looks like a Taylor series centered at, in this case, 2. This, if you were to actually expand this out and simplify, combine all like terms, it'll be equivalent to that. It's just a polynomial. So that's that. Yes. Yes. Boop, boop, boop. What? Whoa. Whoa. Find the functions with the following. Okay. So this is where just kind of knowing the formulas, the ones that I told you to memorize. So seeing the kind of pattern here, I see signs alternating, and I see this x cubed over 3 factorial. So I see odd powers. It's making me think of sine. So I wrote out sine. This is what sine looks like. Now this isn't exactly sine, but it's close. First of all, I can, in place of x, it looks like there's a 5x. Because if I just write this as 5x cubed, 5x to the 5th, 5x to the 7th, I get those. But there's something funky happening in the beginning. Because for sine, the first term should just be x. And in this case, in place of x is 5x. But I don't have a 5x here. I have a 1. So I have an extra 1 that I'm just going to put on there. And I want to have a 5x, but I need to subtract it off. Kim, are you talking about math?
Yeah.
Okay. Okay. So if you were to take this part off, now it looks like sine, except I didn't have the 5x there. I had a 1, so that's why I have these 2 extra terms in there. And that's where the 2 extra terms come from here. Any questions on that? Did you want to ask a question, Kim?
I'll ask you later.
Okay. Any other questions? Taylor series are fun. Wait until you see today. I think it's actually kind of cool, but whatever. Let me go ahead and have your homework, please. Oh, Mary and Rita. All right.
Oh wait, there's more. Oh wait,
Let's see, reality check. Oh. I'm just kidding, there's no reality check. You are saved. Hey, look at that. Why do we keep disconnecting? It doesn't really matter. I'm not going to use this. All right, so it's a little early, but timing just, didn't work out exactly right, unfortunately. What is happening in a couple of weeks? Roughly a couple of weeks. 13 more days to be precise.
Which end?
Pi Day! Excellent! Yes! 13 days from now is March 14th. It is Pi Day. So I have a little something special that you guys are just going to love. It's using Taylor series to approximate pi. Right? What? Yeah. The actual Greek letter pi. But, so, I'm actually going to give this to you guys now. Some of you guys are sitting in areas where, you're not with the group. I really encourage you to move around, work with people on this. But I'm going to give you the vast majority of the period to work on this. You probably do not have enough room. I'm not collecting this, so it's up to you, but you probably don't have enough room to really show your work for everything here. I would, if I were you, pull out a separate sheet of paper to work on. But it kind of works you through. It's like a self-guided tour of how to use Taylor series to approximate pi. But you practice Taylor series. You're going to practice the alternating series error bound in this. You practice using that formula, the 1 over 1 minus x. There's a lot of good stuff in here that's going to help you get ready. The only thing that's really not here is using the tests for convergence. But this is really the second day of Taylor series, so it's really focusing on that. So I'm going to give you guys this. Why are we talking so much today? Oh my God, it's really this group. And he's still talking. Let's all stare at him. I'm going to give you guys this. Let's say, I don't know. The clock is throwing me off. How about, well, we'll check in at 11 and see how your steam is going. I mean, you may not get done with everything by 11, but if it looks like most people have totally deviated from working on this, then I'm going to, well, we'll check in at 11 and see how you're doing. Yeah, I would say try to get to number 11 on this, on the back side. If 12 and on, 12 through 17 is like kind of bonus. It's just more practice with the same stuff. It goes a little further. Try to get to number 11 on this. So I'm going to give it to you. There you go. There you go. And I shall pause the video. If you're watching this video, you can go to Canvas and get a copy of the Finding Pi worksheet. Try working through it, but I'll have the solutions posted in Canvas too.